Greek fire. It began in the late 7th century when the Byzantine Empire stood surrounded by enemies. Arab fleets pushed across the Mediterranean, threatening Constantinople itself. The empire's survival balanced on the edge of a matchstick. Then came a man named Lycurgus, an architect or perhaps a chemist from the city of Heliopolis in Syria. He arrived at the Byzantine court with a secret, a formula, he claimed, that could set the ocean itself ablaze. The emperor listened, and soon the world would witness a new kind of war. When the enemy fleet approached the walls of Constantinople in 672 CE, Byzantine ships sailed forward, carrying bronze tubes mounted on their decks. From those nozzles erupted streams of blazing liquid, roaring, writhing, unstoppable. Arab chroniclers described men leaping overboard as the sea itself ignited. The defenders said the flames howled like living things. Even water could not quench it. Buckets only spread the fire wider. It hissed and burned across the waves like molten metal, and the enemy retreated in terror. The Byzantines had turned nature's most trusted element, water, into their ally, and with it they kept their empire alive for nearly 800 more years. The ingredients of Greek fire became the empire's most guarded secret. Even generals didn't know the formula. It was whispered only to the emperor and a handful of engineers in the imperial workshops. When the last of them died, so did the knowledge. No surviving text records its full recipe, only fragments, hints, and fearful awe. Modern historians have spent centuries chasing its ghost. Petroleum, sulfur, pine resin, quicklime. These ingredients appear again and again in the theories, but none reproduce the weapon's terrifying behavior. Some clues lie in eyewitness accounts. Anna Komnene, the emperor's daughter and historian, described a fiery mixture projected through bronze tubes that could set even the waves aflame. Arab chroniclers told of sailors watching the sea itself burn, calling it the thunder of the sea. To them, it wasn't science, it was sorcery, but there was method beneath the madness. Byzantine records mention liquid fire stored in bronze vessels, sealed tightly until battle. It wasn't merely oil, it was engineered, a chemical weapon centuries ahead of its time. One theory suggests they harnessed petroleum distillation long before it appeared in later Islamic or European alchemy. By refining crude oil into a lighter, more volatile form, they could create a fuel that ignited even on water. Others propose the key lay in quicklime, a compound that reacts violently with moisture, producing both heat and ignition. Combined with sulfur and resin, it could explain the unstoppable blaze. But even these theories can't fully match the accounts. Replicas made in modern labs burn, but they don't roar. They don't cling to water. They don't breathe like Greek fire was said to. In 2008, researchers from the University of Thessaloniki tried to replicate it using asphalt, pine resin, and naphtha. Their mixture burned ferociously, but it lacked Greek fire's eerie behavior. When doused with water, the flame died instead of flaring back to life. That was the moment they realized something unsettling. Even with our chemistry, we can't recreate what a medieval engineer once knew by hand and instinct. As centuries passed, the empire's strength waned. Enemies adapted, supplies dwindled, and one day the secret simply disappeared. When Constantinople fell in 1453, the formula was already lost. The great flame that once guarded its walls had burned for the last time. Today, all that remains are fragments, bronze tubes recovered from shipwrecks, charred residues on amphorae, and terrified chronicles written by men who saw the impossible. Some modern historians claim the story is exaggerated. They say Greek fire was nothing more than a mix of crude oil and resin, a primitive flamethrower, not a miracle. But that theory ignores the countless reports describing its reignition on water and its self-propagating behavior. The Baghdad Battery. It was 1938. In the dust and heat outside Baghdad, German archaeologist Wilhelm König brushed dirt from a small clay jar. It didn't look like much, just another artifact from a Parthian-era dig near Kujut Rabu. But when he lifted it, the jar rattled softly like something metal was hidden inside. He cracked it open and found a strange assembly, a copper sheet rolled into a tight cylinder sealed with asphalt, and enclosing an iron rod that didn't touch the copper. It was unlike anything else found in the region. At first, no one cared. It was catalogued as a storage vessel, perhaps for scrolls or sacred oils. But König couldn't shake a feeling that this wasn't ordinary. He kept studying the jar, the materials, the construction, copper, iron, bitumen, each chosen deliberately. Then he made a bold suggestion that would ignite a controversy lasting nearly a century. What if this ancient clay jar was a battery? The claim sounded absurd. Electricity wasn't supposed to exist until 2,000 years later, when scientists like Volta began experimenting with chemical reactions, and yet König's battery could, in theory, produce a charge. In the 1940s, researchers filled replicas of the jar with grape juice and vinegar, simple acidic liquids. The results were astonishing. Each vessel produced around 1 volt of electricity, enough to tingle your skin, enough to power a tiny device. In the 1970s, experiments went further. When connected in series, the recreated jars generated a small but steady current, not enough to light a room, but enough to coat metal with a thin film of another. Electroplating. Could it be that ancient craftsmen used this device to plate gold or silver onto jewelry? Some archaeologists pointed to artifacts from the same period, objects whose surfaces bore chemical traces of copper plating. Others proposed the jars might have served medical or ritual purposes, used to deliver mild shocks as part of healing or spiritual ceremonies. Whatever the case, one thing was clear. This wasn't random. It was intentional design. If they truly harnessed electricity, how far did that knowledge reach, and why was it abandoned? No ancient text mentions energy or current. No tools, wires, or schematics have ever been found beside the jars. And yet the physical evidence refuses to go away. Even without written proof, the architecture of the Baghdad battery feels too deliberate to ignore. A metal inside a metal, separated by an insulating layer of bitumen, precisely what's needed to prevent short-circuiting. It's as if the builder understood the invisible dance between charge and matter without the words to describe it. Skeptics have fought back against König's theory for decades. They argue the jars were simple storage containers. Perhaps they held scrolls or sacred papyri rolled inside copper to preserve them from humidity. Or maybe they stored ritual oils used in temples, sealed to prevent leakage. Those are valid explanations. But then, why include an iron rod, insulated and suspended exactly in the center of the copper cylinder? Why construct something that mirrors a primitive galvanic cell so perfectly? In modern labs, scientists have reconstructed the device many times. When the recreated Baghdad batteries were filled with vinegar or lemon juice, they could power small bulbs, drive electrochemical reactions, or coat coins in a thin metal film. It wasn't powerful, but it worked. That realization sent shock through the field of archaeology. Because if these jars were truly ancient batteries, then humanity's understanding of electricity didn't begin in the Enlightenment. It began in antiquity. And that would mean the story of science is far older and far stranger than we've ever imagined. If the ancients stumbled upon electrical energy through experimentation, they may not have had a scientific framework to explain it. Perhaps they saw it as divine, a manifestation of the gods' power, a hidden force that could heal, protect, or curse, and so instead of studying it, they ritualized it, used it for magic, for medicine, for mystery, until the knowledge, unrecorded, unshared, simply faded. What if the Baghdad battery isn't an anomaly, but a reminder that our ancestors sometimes spoke the language of science through religion, art, and myth? Today, the Iraq Museum in Baghdad keeps several of these artifacts under glass. They look simple, almost unimpressive, small, clay, ancient. But behind that humble surface lies one of archaeology's most provocative questions. Was it a fluke, a misinterpreted container, or proof that an ancient mind, long forgotten, understood something modern science would only rediscover 2,000 years later? No one knows. In the end, the Baghdad battery remains a paradox, either an ancient accident or a silent testament to knowledge far beyond its age. It forces us to ask what else our ancestors might have known, and what secrets they carried to their graves. Because if this small clay jar could hold a spark, then what greater light might have once burned in the dark? The Antikythera mechanism. It began with a storm. In the spring of 1900, a small group of Greek sponge divers was caught off the coast of the tiny island of Antikythera, between Crete and Kythera. They weren't explorers or archaeologists, just men trying to earn a living from the sea. To escape the waves, they dropped anchor and dove for sponges in the shallows. At a depth of nearly 150 feet, one diver saw something that shouldn't have been there. Bodies, lifeless, ghostly shapes scattered across the seafloor. Bronze arms, stone torsos, marble eyes staring through centuries of silence. He had stumbled upon the wreck of an ancient ship. When archaeologists arrived months later, they began hauling up treasures, marble statues, coins, and amphorae. But among them was a lump of corroded bronze, barely recognizable, fused into rock. No one paid it much attention. It was catalogued, boxed, forgotten. Years later, when museum workers began cleaning the encrusted object, small metallic teeth appeared beneath the corrosion. Not animal teeth, but those of a gear. What they held in their hands wasn't art nor jewelry. It was machinery. And that single detail, those delicate interlocking teeth, would one day rewrite everything we thought we knew about the ancient world. For decades, the artifact sat in pieces, misunderstood. Then, in the 1950s, British physicist Derek de Solar Price took a closer look. Using X-rays, he discovered that the device wasn't just one gear, but dozens, arranged in a complex system of interlocking bronze wheels. Each gear was cut with such precision that it could predict the movements of the sun, moon, and planets. By the early 2000s, new imaging methods, CT scans and 3D X-ray tomography, revealed its true nature. Inside that corroded shell were 37 bronze gears, all calibrated to turn in unison. Greek inscriptions labeled celestial cycles, eclipses, and even the Olympic calendar. It could model the irregular orbit of the moon, something that requires understanding the moon's elliptical path and variable speed, concepts no one believed the ancients could calculate. Researchers compared its complexity to an 18th century clock, but this machine predated the first mechanical clocks by more than 1,500 years. It was a computer, a device for predicting the heavens, hand-built in a world that shouldn't have known how. How could a civilization that lacked telescopes produce a mechanical cosmos in miniature? The question still haunts every scholar who's ever studied it. The fragments we have, just 82 in total, show only part of the original device. Its casing is gone. Its inscriptions are half erased. No second example has ever been found. Some believe it was crafted by a lone genius, possibly a student of Archimedes, whose own works hinted at celestial spheres and mechanical calculation. Others think it came from a lost workshop, a school of engineers whose knowledge never survived. If so, then the Antikythera mechanism wasn't unique at all. It was a survivor of an entire forgotten tradition. If this mechanism was truly unique, who taught its maker? And if it wasn't, where are the others? Modern reconstructions have proven that it works. Turn a hand crank, and the gears rotate the dials that once displayed the moon's phases, planetary positions, and eclipse predictions. It could even forecast lunar and solar eclipses decades in advance, based on the 2 to 23-month Saros cycle. Some believe sailors or philosophers used it to understand the will of the gods written in the stars. Others think it was a teaching tool, an instrument for kings, showing how the cosmos turned like a perfect machine. But then it disappeared. The ship carrying it sank sometime between 70 and 60 BCE. Soon after, Greece fell under Roman control. Within centuries, mechanical science, this strange, intricate understanding of gearwork, was gone. For nearly 1,000 years, humanity forgot how to build machines like it. What could erase a technology this advanced from memory? Some say secrecy. The knowledge may have been guarded, shared only within elite circles of philosophers. Others suspect catastrophe, libraries burned, workshops lost, scrolls destroyed in conquest and fire. But there's a darker possibility. Maybe the world simply chose to forget. Did knowledge die, or was it deliberately hidden, waiting for a world ready to understand it? We often think of progress as a straight line, one invention building on another, an unbroken climb from ignorance to enlightenment. But the Antikythera mechanism tells another story, one where genius can vanish and history can turn back on itself. It suggests that intelligence, like civilization, may be cyclical, that perhaps every great leap forward leaves behind a shadow, a memory of something greater, erased and rediscovered again and again. Today, scientists have reconstructed its functions with 3D models and working replicas. Yet even now, there's debate about its missing pieces. Some inscriptions reference planets like Venus and Saturn, suggesting the original may have tracked all 5 known ancient planets. Others point to an unknown upper gear assembly, lost to time, that could have encoded even more astronomical data. In 2021, researchers at University College London proposed a new design, showing how all known fragments fit into a complete mechanism. It worked beautifully. But it also raised another question. If one artifact like this existed, why has no trace of the same knowledge survived anywhere else? The Roman concrete. In the heart of Rome, sunlight spills across the massive dome of the Pantheon. For nearly 2,000 years, it stood untouched by time. No steel, no modern cement, just stone and an ancient mix of earth, water, and ash. Across the Mediterranean, in the harbour walls of Pozzuoli, waves have slammed against Roman concrete for centuries. The sea has devoured ships, eroded cliffs, and buried empires. But not these walls. They remain solid, almost alive. How? Archaeologists and engineers have puzzled over this paradox for decades. Buildings made in the modern world crumble within decades. Yet Roman harbours, aqueducts and domes, structures born before the age of machines, seem to resist time itself. The answer, it turns out, lies not in their stones, but in their chemistry. The Romans called their material opus caementicium, a simple mix, at least on paper, volcanic ash, lime, seawater and stone. But that recipe hides a secret far deeper than it appears. When researchers from MIT analyzed Roman concrete under powerful microscopes, they found tiny white fragments scattered through it, microscopic lime clasts. At first, these were dismissed as imperfections, flaws. But when samples were deliberately cracked and exposed to water, something extraordinary happened. Those so-called flaws reacted with moisture and healed the break. Minerals grew across the fracture, sealing it shut, as if the concrete were regenerating itself. A material that heals. That's not a metaphor. It's literal chemistry. Modern engineers call this process self-healing concrete. We only rediscovered it a few years ago, almost by accident. But the Romans had it all along, and unlike us, they built with the knowledge that their structures would endure centuries, not decades. Did the Romans truly understand the chemistry? Or did they stumble upon genius by experiment alone? That question still divides scientists. Ancient texts, like Vitruvius's De Architectura, describe the use of volcanic ash, pozzolana, mixed with lime. He warned that only certain regions like Baiae and Cumae produced the right kind. But he never wrote down the ratios or explained why it worked. Perhaps the recipe was a closely guarded secret among Roman builders. Perhaps it was intuition. Centuries of hands-on experimentation, refined through observation rather than theory. Whatever the path, the result was miraculous. Modern tests show that Roman-style concrete doesn't just last, it grows stronger with time. When exposed to seawater, its volcanic ingredients react with salt and minerals, forming rare crystalline structures called aluminum tobermarite. That's the same material modern scientists struggle to synthesize in labs. And here it was, forming naturally in harbour walls poured by hand over 2,000 years ago. Today's concrete is brittle. Within decades it cracks, crumbles, and demands repair. Our skyscrapers, bridges and highways, monuments of modern engineering, are temporary by comparison. Yet the Romans, working with no computers, no rebar, no industrial process, created structures that refused to die. At Portus Julius, the remains of ancient piers still sit beneath the waves, their surfaces hard as rock. Tests reveal that the concrete's strength has increased since it was poured in 37 BCE. It didn't decay. It evolved. That alone should humble us. So why did this technology vanish? Why didn't medieval builders inherit it? Why, when the empire fell, did the knowledge fade into oblivion? Some scholars blame the loss of supply lines. Rome's volcanic ash came from specific Italian sites, especially Pozzuoli, and those sources fell into enemy hands as the empire fractured. Others point to cost. The process was slow, the ingredients rare, and the craft demanded a precision no longer profitable in an age of haste. There's also a darker explanation. The Christianization of labor guilds in late antiquity broke the chain of technical inheritance. When temples closed and guilds disbanded, the builders' secrets went with them. By the Middle Ages, the formula was gone. Europe had forgotten how to make a material that resisted time itself. And that's the irony. Modern civilization, armed with supercomputers and global trade, spends trillions repairing roads and buildings every year. Yet the answer to permanence was already known 2,000 years ago, written in ash and lime. Scientists at MIT now attempt to revive it. They experiment with mixtures of volcanic ash from the same regions the Romans once mined. They test the lime clasts, heat the materials, and submerge samples in seawater. Some achieve similar results. It's humbling and a little haunting to think that our modern innovation is really just reconstruction, a rediscovery of something humanity once mastered, then lost to time. If this living concrete can teach us anything, it's that progress isn't a straight line. It's a fragile memory passed from one civilization to the next, and when that memory breaks, we begin again, forgetting we've walked this road before. The Pantheon still stands, its dome unreinforced, its oculus open to the sky. Rain falls through the opening, hits the marble floor, and drains away, just as its builders designed it to. And as modern engineers look back, one thought lingers. Maybe the future of construction lies not ahead, but behind us. In a world where knowledge loops like a spiral, where progress is rediscovery, and genius, remembrance, Roman concrete stands as both triumph and warning. Proof that endurance is possible when wisdom is valued more than speed. A reminder that even the strongest foundations can crumble, not because they fail, but because we stop remembering how to make them. The Lycurgus cup. In the dim halls of the British Museum, behind glass and soft light, sits an object unlike anything else from the ancient world. A Roman cage cup, 2,600 years old, its surface carved with a myth frozen in motion. King Lycurgus, entangled by vines, punished for defying the god Dionysus. The craftsmanship alone is stunning. Delicate figures, glass so thin it seems to breathe. But its real magic reveals itself only when light touches it. When lit from the front, the cup gleams a deep emerald green, but when light shines through it, it turns a rich blood red. One object, two colors, one truth that refuses to stay still. When scientists first studied it in the 1950s, they were baffled. No pigments, no coatings, just glass. How could color shift like that? It wasn't until the 1990s, under electron microscopy, that the secret finally emerged. Embedded throughout the glass were particles of gold and silver, so tiny they were invisible to any ancient eye. Just 50 nanometers across. That's smaller than a virus, smaller than light itself. The Romans, 2 millennia ago, had somehow engineered matter at the nanoscale, a feat modern science only achieved in the last century. When light hits the cup, electrons on the surface of those nanoparticles vibrate, resonating with specific wavelengths. It's called surface plasmon resonance, a phenomenon first named in the 20th century. In simpler terms, the cup's color doesn't come from dye or pigment. It comes from the dance of light and electrons. Front light? The electrons absorb and scatter shorter wavelengths, green. Backlight. They transmit longer wavelengths, red. The result is a living color shift, controlled by the physics of the invisible. The Lycurgus cup, in essence, is a nanophotonic device, built before the word atom even existed. How could artisans with crude furnaces and tongs have mastered atomic-level precision that modern labs only rediscovered with electron microscopes? Some historians suggest they didn't understand the science, only the outcome. Perhaps after centuries of glassmaking, They noticed that certain metal shavings added to molten glass created strange colors. Perhaps they refined that observation into a formula, handed down, tested, and perfected. But the consistency of the cup, the even dispersion of particles, the stability of the color, the perfection of its optical effect, suggests something beyond accident. Even more remarkable is what the cup represents. When light interacts with its surface, electrons on the metal nanoparticles oscillate collectively, transforming how light itself behaves. This is the same principle used today in biosensors, quantum optics, and photonic computing. Modern engineers studying the Lycurgus effect have applied it to detect viruses, toxins, and even single molecules of disease. A Roman artifact, used as a template for modern nanotechnology. Maybe the difference between science and art is only language. The cup's construction only deepens the mystery. Its outer cage was carved separately from the inner shell, then fused together with surgical precision. Its imagery, Lycurgus strangled by vines, seems symbolic, even prophetic. Man ensnared by what he sought to control. Perhaps unknowingly, the artist captured not just a myth, but the essence of scientific paradox, beauty born from chaos, mastery born from surrender. No other Roman glass matches its perfection. Many have tried to replicate it. None have succeeded entirely. There are fragments, other pieces from the same era found across the empire, that contain traces of similar nanoparticles, but their dispersion is uneven, their colors dull, unstable. Skeptics still argue, perhaps it was a fluke, a happy accident, a contaminated batch of sand mixed with dust from a gold workshop. But this explanation feels thin, because even the imperfect glass from that same period shows controlled ratios of gold and silver, and ratios require measurement. Measurement requires method, and method means intent. If this was an accident, it was one repeated with remarkable precision across decades. Perhaps the ancients didn't lack science, they just spoke it in the language of art. To them, the world was alive. Materials weren't inert. They were infused with divine potential. To heat metal, to melt sand, to shape light. This wasn't engineering. It was alchemy, a sacred transformation. And maybe that mindset, that reverence for material mystery, was what allowed them to reach depths modern minds rarely touch. Today, physicists studying the Lycurgus cup marvel not just at its beauty, but at what it implies, that a civilization long dismissed as primitive had already manipulated light at the quantum level. Time has not dulled it. The nanoparticles remain stable, suspended in their glass matrix, untouched by corrosion, air, or decay. Even now, centuries later, its colors shift with the same brilliance they did in Rome. That's not just durability, that's permanence through precision. It's easy to imagine the awe of those who first held it by candlelight, watching red bleed into green, unaware that they were witnessing physics no one would name for 1,500 years.